In the last video, we introduced operator overloading. In this video, we'll see how objects can overload a specific operator such that they can be called like functions. A callable object, sometimes called a function object, is any object that defines its own overload for the function call operator. This operator is overloaded with the name operator open close parentheses. Note that the parentheses in the operator function name are different from the parentheses used to mark out the parameter list. Any object whose class defines this operator can be called as if that object were a function. Let's take a look at an example. In this short example, I've created a new struct called parametric quadratic. This is a structure that will represent a parameterized quadratic equation. So it has the three values that define a quadratic equation, and then we have a function call operator overload that takes in the x value for the equation. Inside of that function overload, we're calculating out the quadratic equation value for that given x and returning it. So we can now use our structure like this. We declare a new parametric quadratic named f, and we initialize the a, b, and c values in its constructor. Then we can call f as if it was a function and give it a value that will be used for x, and it will return us the double that it calculated with the quadratic. So in this case, when we initialize it with the parameters 1, 1, and 0, and then call it with the value 5, we get the return value 30. Notice the const keyword that shows up at the end of this operator's signature. This tells us that the body of this operator is not allowed to change the object that it was called on. For the purposes of this operator, that object is constant. In general, any operator that doesn't change the object that it's part of should be marked as constant. While a constant operator can be called on a non-constant object, the other way around is not supported. If an operator is not constant, I can't call it on a constant object, because the compiler knows that that operator is allowed to modify the object, but if our object is constant, it shouldn't allow any operations that would modify it. Most operators will end up being constant, but there are some, notably the variations on the assignment operator, that don't follow that rule. Being able to create callable objects in this way is a critical part of a couple different powerful patterns and features in C++. These will often show up anytime your code wants to work with callbacks, predicates, and more. We'll introduce a language feature that uses callable objects in the next video.